Algebra 2 6.8a solve rational formulas for a specific variable. Now we talked about this a little bit in the previous video. We now have 14 videos for Chapter 6, and if you haven't seen them, you can click on this video's description and watch those so you don't become lost. To solve rational formulas for a specified variable, our goal is going to be to solve an equation for one variable in terms of the other variables. And we may later use this equation to find numeric solutions. So look at this. The volume V of a pyramid with a square base of length L and altitude h is given by V equals 1/3 L squared h. We solve for h in terms of L and V. So we can rewrite this and make it so it's solved for h. The first thing we do is multiply by the reciprocal of 1/3, and that will create a 1 right here, and we'll get 3v on this side. Then we can divide both sides of the equation by L squared, and that will leave us with 3v over L squared equals h. See? We flipped it around in case we needed to find the height, the altitude, okay? So we can flip formulas around. So in the last video, we did this with the d equals rt, the distance equals rate times time, didn't we? So we could solve this for t. Right now it's set as d equals. So we want it to be t equals. So all we have to do is divide both sides by the r. That creates a 1, and now we have d over r equals t. We've solved it for t. Look at this formula. PV over T equals K, and this relates to pressure, volume, and temperature of gas. And we can solve it for the T by multiplying both sides of the equation by T. This cancels out as a T over a T as a 1, and we have PV equals KT. Now, that is the same thing as this, isn't it? Because it's just over 1s. We can divide each side by the K to isolate the T, and it'll be solved for T. We divide this side by K and this side by K. That creates a 1. We cancel it out, and we're left with PV over K equals T. See? It was solved for the T. Take a look at this one. Got some baseball here for you. The formula for calculating a pitcher's earned run average, it's shortened as an ERA in baseball, is A, that average equals 9 times the runs divided by the innings. As A is the earned run average, R is the number of earned runs, and I is the number of innings pitched. We know the earned run average and the number of earned runs. We can find the number of innings pitched by solving the formula for I. We multiply each side of the formula by I, and we get I times A over 1, which simplifies to just I times A, and this becomes 9 times R over 1, which simplifies to 9R. Now all we have to do is divide both sides of the equation by this A, and we'll isolate the I, won't we? That turns into a 1, and now we have I, the innings, equals 9 times the run over the average, see? We can calculate the number of innings pitched if we know the pitcher's ERA and the number of runs the pitcher gave up. We just switch that formula around to fit our needs to find out what we wanted to find out. Did you know Cy Young was a famous great pitcher from 1890 to 1911? That was over 100 years ago. All right, take a look at this one. If we wanted to solve this one for D sub 1, remember this little 1 down here is a sub 1. It tells us which D it is, because we have a D here and a D here. This is sub 1, that's sub 2. We have W sub 1 and W sub 2. Okay, it's a subscript, so they just say sub 1 or sub 2. So if we wanted to solve it for D sub 1, all we have to do is multiply both sides of the equation by D2, D sub 2. That cancels that out as a 1, and we're left with the D sub 1 over a 1, which is really just D sub 1, isn't it? And on this side, we have D sub 2 times W sub 1 over W sub 2. And we've solved it for D sub 1, see? Take a look at this one. This one's a little bit more confusing looking. We have S equals half V sub 1t plus half V sub 2t. They want us to solve it for V sub 1. That's that guy right there, isn't it? So we're going to remove the fractions by multiplying by the reciprocals. So we're going to multiply this by 2 over 1, this by 2 over 1, and this by 2 over 1. And that gives us a 2s here. That creates a 1, so we get rid of it. That creates a 1, so we get rid of it. And we're left with V sub 1t plus V sub 2t. Now to isolate the V, because remember we're trying to solve for V sub 1. To isolate V sub 1, we can add a negative V sub 2 to each side. That'll give us a 2s minus V sub 2t here equals V sub 1t. Now, to isolate that more, we just divide each side of the equation by that t. That cancels out as a 1, and we're left with 2s minus V sub 2t over t equals V sub 1. See? So it's a lot of multiplying and using additive inverses, just like you would with any other algebra problem, and we solve for that variable, okay? It's not that hard, all right? So our next video is 6.8b, and we're going to solve rational word problems with formulas. I'm going to put this video into the Algebra 2 playlist, and there's a video from Algebra 1 3.7 where we did this in a little bit lighter way. We didn't go into such heavy topics as this, but we did the same thing. We switched formulas around, so you might want to watch that. That link will be in this description, along with the current chapter 6 videos that we've been working on, okay? That way you can just click on them, watch them, and you don't have to look for them, all right? Take you right to the playlist, and you can watch each video after each video, and you'll be all set for when you take a test because it'll be fresh in your mind, okay? The way the math works is if you don't keep using it, you slowly forget it, okay? So the trick is to watch a video every once in a while from previous chapters so that when you have a semifinal or a final test coming up, you'll remember it a little bit, okay? I'll see you next video. Bye.